Here's a couple of the questions from the quiz review that I wanted to make sure you understood well. Number 6 asked you to solve for y. 3x minus 2y equals 14. When you're doing these types of problems, you want to isolate the variable on a side of its own. That's the first thing you want to do, and get everything else on the other side. So we want to solve for y. So that means I want the y to be on a side all by itself. So let's get this 3x over to the other side by subtracting 3x from both sides. Now you have negative 2y equals negative 3x plus 14. And then you would divide each term by negative 2. Remember, each term, meaning anything separated by a plus or a minus sign, needs to get divided by that negative 2. And so I'm left with negative 3 divided by negative 2 is 3 halves x. 14 divided by negative 2 is minus 7. It also in that question asked me to evaluate y if x was equal to 6. Well, since I just solved for y, I really want to plug in the x right here. I don't want to go back to my original problem because then I would have to be repeating all the steps that I just did. In number 7, they ask you to solve for y. So we have 3xy minus 4x equals 19. Same thing, we need to isolate the y on a side all by itself, get the 4x to the other side. In this problem, you then have 3xy equals 4x plus 19. And so you would divide both sides by the 3x because you want the y all by itself. Divide by 3x on this side, divide by 3x on this side. It is fine to leave your answer like this. Or, like I just said there, divide each term separately so that I get 4x divided by 3x. X divided by x is 1, so you just get 4/3 plus 19 over 3x. Either this answer or this answer work really well. It also asks you to evaluate if x equals 2, so you just plug that in. Number 8 is a little bit trickier because you have a y in here and you have a y here, and then you have equals 9. So I already have isolated the variable on a side all by itself. All the y stuff is already on the left, but this one has a y in it and this one has a y in it, and I don't have any like terms to combine. So what I need to do is I need to factor out the y because I want to solve for y. So I need to isolate it even further. By factoring out, I mean that you go 11y divided by y, because I'm factoring it out, is 11, and then 2xy divided by y just leaves you with the 2x. So you'll have y times 11 plus 2x equals 9. Then you just divide both sides by the 11 plus 2x, and you get y equals 9 over 11 plus 2x. In number 11, you have a problem where it says that all of your lessons cost the same amount except for the first lesson, which is 1.5 times as much as all the other lessons. It says that you take a total of 10 lessons and it costs you $315. Well, if you have taken 10 total lessons, that means that you had one of the first lessons, which means you have 9 more lessons. So one of those 1.5x's, so I don't need to write 1 times, one of those, and then you have 9 more of the rest of the lessons, which costs the same amount. And that should be your total of $315. So again, this is the first lesson, and then you have 9 more because it said you had 10 lessons total. And then you just go ahead and solve it. When it asks you how much of the first lesson cost, remember that you just solved for how much the rest of the lessons cost. So you need to make sure that you multiply that by 1.5 since the first lesson was 1.5 times as much as the rest. In number 12, it said that you have lilies and peonies, and you have a total of 12 flowers. That total of 12 flowers is key because if you have x lilies, it means that you have 12 minus x of the peonies because you have 12 flowers total. This is just like the lemonade and slushy lemonade problem that we did in the PowerPoint. So if the lilies cost $3.50, $3.50 times x of those lilies, and the peonies cost $5.50, then 5.5 times how many you have, 12 minus x, that would be the total cost which is $52 that you have. You have $52 to spend. It's asking how many lilies and how many peonies can you buy. The key to number 12 here is that you have 12 total, so that would mean that you don't need to have an x and a y variable separately. If you have x of one, you have 12 minus x of the other. Some other problems that I wanted to go over were from 1.1, number 48. In number 48, I forget what the exact problem was, but it said that in 60 seconds, you could rise 500 feet. So if we're talking about a rate, and it asked you to actually put this in miles per hour, which is your big hint, because a rate is always distance over time, and since it tells you already miles per hour, you want to make sure that you have the feet part in the top and the seconds in the bottom. So if it tells you a unit for your answer, then that's kind of a hint. So when we put that 500 feet over 60 seconds, we want it in miles per hour. So I'm going to tackle the miles first. So I know that there are 5,280 feet in a mile. I want to cancel out feet with feet. So I know that the feet part goes in the denominator. And since there are 5,280 feet in 1 mile, the 5,280 has to stay with the feet. Then, in order to convert seconds to hours, again, seconds is on the bottom, so I want to be able to cross it out with something on the top. I'll put seconds on the top. There are 3,600 seconds in 1 hour. The 3,600 goes with the seconds because there are 3,600 seconds in the hour. And then those units cancel out with those. You're left with miles per hour. And then in your calculator, you can do the calculation. You should get 5.682 miles per hour. In number 62, this is a lot like the lilies and peonies example that we did in the quiz review. It says that there are 80 workers total, and they can either have a desktop or a laptop. Well, if X of them choose the desktop, then that would leave 80 minus X of them to choose the laptops. Again, you have 80 workers. The cost of the desktops, it says, is $900, and the cost of the laptop is $1,550. So we multiply the cost times the number of desktops, the cost times the number of laptops, and that's my total cost. In the second part of the problem, it said if 65 choose desktops, what is the cost? If 65 of them choose desktops, I can just use my simplified thing right here. X was desktop, so I can just use my simplified equation to find the total cost. On the quiz review on page 16, that said that CDs cost $8 and you have a gift card for $100. If you purchase NCDs, how much money do you have left? Well, you have $100 to start with, but then you buy CDs, which cost $8 a piece. If you bought one of them, it would be 100 minus 8. You bought two of them, it would be 100 minus 8 times 2. What do? 100 minus 8 times however many CDs you bought. If you purchase 6 of them, just plug in 6 for the n above. On 1.3, number 54, it gave you a parallelogram, and it said that these two sides were 12x minus 2, and then these two sides were 10 minus x. And so the perimeter, you just sum up all the sides. Well, since there were 2 of them that were 10 minus x and 2 of them that were 2x minus 2, I just wrote 2 times 2x minus 2 plus 2 times 10 minus x would be the perimeter. And so I distributed and combined like terms. And then it had told me that the perimeter was 26. So I just used that simplified expression I just found, set it equal to 26, and I found that x was 5. Now you got to read the problem. It says that what are the side lengths? Well, one of the side lengths was 2x minus 2, stick in a 5, you get out an 8. The other side length was 10 minus x, stick in a 5, 10 minus 5 is 5. On 1.4, number 28, we did this in class, but I just want to do it once more. You want to solve for y in this problem. So the first step is to isolate the y on a side all by itself. The y is over here and over here. So let's get all the y's on the left. So I need to subtract y from both sides. That leaves me with xy minus y equals x. Now isolate that y further. So let's factor it out. So we have y times xy divided by y leaves you with x. Y divided by y leaves you with minus 1 equals x. Divide both sides by x minus 1, and you get y equals x over x minus 1. In number 29, we want to solve for z. So we need to get all the z's on the left-hand side, get this z over there by subtracting z from both sides. Again, factor out that z. xyz divided by z is xy. Z divided by z is 1. So we have z times the quantity xy minus 1 equals x plus y. Divide both sides by xy minus 1, and we have our answer. In number 30, we're dealing with fractions, and so if we multiply through every single term by the common denominator, then we can get rid of our fractions. So xy is our common denominator in number 30. Multiply each term by xy. Well, xy divided by x leaves us with y. Xy divided by y leaves us with x. And then 1 times xy is just xy. Now I want to solve for y in this problem. Get all the y's on a side all by themselves. So first I'm going to put this xy over on this side by subtracting xy from both sides. I'm left with y minus xy plus x equals 0 because xy minus xy is just 0. But the x, I don't want to solve for x, I'm solving for y. I want to get that on the other side. Again, you want to get the y on a side all by itself, everything else on the other side. You do that before you do any division or multiplication. So we're left with y minus xy equals negative x. Isolate that y by factoring it out. Y divided by y is 1. Xy divided by y is x. So we get y times the quantity 1 minus x equals negative x. Divide by 1 minus x on both sides. If you had done it a different way, meaning like if you had put the y over on this side, you would have been left with y equals x over x minus 1. That is a perfectly good answer as well. I don't care which of these two answers you got, they're both equivalent. In number 31, again, I'm going to do the same exact thing. I don't want to deal with these fractions. I'm going to multiply through by my common denominator. In this case, it's x, y, z. Multiply everything through. x, y, z, x, y, z, x, y, z, x, y, z, because I have to multiply each term. So we're left with xyz divided by x is yz. xyz divided by y is xz. xyz divided by z is xy. And then I have the xyz on this side. I'm solving for z in this problem. So here I have a z, here I have a z, but I also have a z over here. I need to get that on the left side. So I'm left with yz plus xz minus that xyz, but I still have this plus xy on the left side equals 0. So I need to get that xy on the other side. Again, I only want the z on a side by itself. Once I've done that, I can isolate it by factoring it out and then divide both sides by the same. In this problem, depending on which side you put things, you could have also gotten this answer here, which is equally as good. Okay, so I hope this was helpful and good luck studying. If you have any questions, please feel free to email me tonight.